Question 6. There's a lot to do here, covering each of the sections of this exercise, but we've started, lots of reading to go through beforehand, but the information we're told is that the chance of the diameter being greater than 5.62 is 5%. And we're going to use that to try and find out what the mean is. Remember, we can standardize this by doing 5.262 minus the mean divided by the standard deviation, which is 0.1, and I'm going to grab my calculator and we're going to do a backwards normal here. So mode 7, the inverse one here. The area we want is a less than, so a 0.95 for this, a standard deviation of 1 and a mean of 0, the usual backwards one there. That tells me we're at 1.6449 standard deviations away. So just now rearranging that, answer times by 0.1 equals 5.62 minus answer gives the mean of 5.46. So we can now use that mean to find out the probability that it can be sold. So it can be sold so long as the diameter is between 5.1 and 5.6. So straight back in here, this time with the normal distribution here, the lower at 5.1, the upper at 5.6. The standard deviation we were told is 0.1, and I've got the mean there in the answer. And so I've got 0.926 is the probability that it can be sold. In part B, we've chosen 12 of them. Now, this isn't the mean of 12. This is now counting how many can be sold, or actually the question says cannot be sold. So X is the number that cannot be sold, then X is a binomial with a mean of, a binomial, N is 12, and the probability of not being sold is the 1 minus that one there. We want the probability that fewer than three cannot be sold. So I'll push pause in a second and tap this into the calculator. So we're going the sum from 0 to 2, because we don't want 3, of 12, choose X, 0.084 to the X, 0.926 to the 12, take away X. So you could have told me I got that wrong. I tapped all of this in and it gave me a value bigger than 1, so I knew I'd done something wrong. And what I'd done is when I went from there to there, I accidentally did the takeaway incorrectly. So this should have been a 7.4. So tapping all of that in now gives me 0.946 as my probability there. Sorry about the mistake. Part C then. C is asking us whether the mean is 5.7 or less than 5.7. And so our null hypothesis is always mu equals something, and this says whether it's less than that. So we're doing it at 2.5% significance, and this time, so we've got y as a normal, a mean of 5.7, and the standard deviation was 0.08, but we've got a sample of 20. And so the mean of the 20 of them will be 5.7, and the variance will be 20 times smaller. And we want to know the probability that y is less than, what do we get? 5.52. 5.52. Let's grab the calculator for that. So I put lower minus loads, upper 5.52, standard deviation, being careful here, 0.8 divided by root 20, and the mean of 5.7, and that's given me absolutely tiny probability. I mean, an absolutely ridiculously low probability. I mean, I've got 4.05 times 10 to the minus 24. I mean, that is so tiny. Then we are going to accept H0. We're going to accept H1 here. I mean, it is massively rare, and so really in that area there. So that is far less than 0.025. Therefore, accept H1 at 2.5%. Evidence suggests the mean is lower than 5.7.